this tutorial, we are going to look at part of light microscope.
This is what we are calling light microscope. It is called light microscope because it uses light to illuminate the specimen. Before we look at functions of various parts of light microscope, kindly remember to subscribe and share widely to support my work. Welcome.
We want to start with the mirror, and the work of mirror, as we all know, is for refraction. The reason as to why we have mirror in the light microscope is for directing light inside the microscope. When you talk of the inside, that's what we are talking about. So you can see it is reflecting light in and off. In, off. So you set the mirror in a way that it directs the light inside the microscope. The next thing that we are going to talk about is the condenser. When we talk of the condenser, we are talking about a system of lenses. If you keenly look at the inside, but because of the mirror, if you allow me, I remove the mirror because it's removable. That is when we can be able to see the inside. So if you keenly look at the inside, you can see some lenses there. Those lenses, we are calling them condenser. And that's why we are saying it's a system of lenses that concentrate. So after the mirror reflects or direct light inside the microscope, now the condenser concentrates light and direct it to the specimen. The specimen is usually on the stage. So the specimen is here. So that is why everything is directed to the stage, to the specimen. So we shall talk about the stage later. As we proceed, be sure to remain here. So from there now we look at the diaphragm. Diaphragm is an aperture just below the condenser, just as we have seen that the condenser is inside the microscope and is a system of lenses. Then whatever is below it is the diaphragm. Diaphragm is an aperture, is an opening just below the condenser, and this opening is used to regulate the amount of light entering the microscope. And we can close and open it. Like now it is open, we can close it. We can open it. So its diameter can actually be regulated depending with the amount of light you want to reach the stage. So if there is too much light, then you reduce the diameter so that we have little light, so that the stage will not be too much illuminated. If there are little light, then you make sure that the diaphragm is fully opened. I hope that is clear. Now we look at the stage. We normally say that the stage is a platform where a slide that contains specimen that we are going to magnify, and we also have some clips. Clips, just like we normally have hair clips, that are used to hold the hair so that in case of wind it is not blown away or it does not fly away. Okay. When we talk of slide, microscope slide, we are talking of something like this one. Okay, this slide has a permanent cell of a plant. So the slide has got the specimen. So that is the slide we are talking about. You put it there and then you clip. Then you clip so that the specimen, the slide does not keep moving. Now we look at the objective. Objective is also a system of lenses located near the specimen. The specimen is here, and what is just above the specimen is the objective. There are usually three different objective with different magnifying power. So we have this one, which is has times 10, and we have this one that has times 4, and we have this one that is times 40. So they have different magnification, and depending on their magnification, now we talk of this one has the highest power of magnification. So this one magnifies the image, the object in 40 times. So whatever you see is usually magnified 40 times. For this case where we have times 10, it is now the medium objective lens that magnifies the object 10 times, and the lower power objective lens magnifies an object 4 times. Now, these objectives are attached to something called nose piece. Nose piece, its work is to attach objective to the body, and it can rotate, so that now suppose you want to use the high power objective lens, you have to rotate so that this one is directly opposite to this, to the stage, so that we can use the high objective lens to magnify. So that's why we are talking of the nose piece is rotatable. We can rotate it so that we can select the type of objective we want to use, whether high, low, or medium objective lens. So you can rotate it depending on whatever you want to use, just like that. Now let's look at the body tube. So the body tube holds the objective and the eyepiece. So when you talk of the eyepiece, we are talking of eyepiece length. You can put it in and remove it. So this is what we are talking about, the eyepiece. So this is the body tube. The whole of this is the body tube, and you can see it is holding the objective and the eyepiece. This eyepiece has a magnification of times 10. Remember, there is some magnification that is taking place here, and then the image that is formed is further magnified by the eyepiece and then projected to the eye. So because when we are using the light microscope, you place your eye here like this. So whatever we normally see is first of all magnified by the objectives, then the image formed by the objective is then magnified by the eyepiece. So whatever I see is the magnification of our objective lens, the one that I choose, and then the image formed here is further magnified by the eyepiece. So if suppose we choose to take the objective lens that has a magnification of times 40, and we have eyepiece of magnification times 10, then it means the image that I see with my eyes is magnified 40 times and then 10 times. So the total magnification will be 400 times. That is how as a microscopic organism or cell can be observed or can be seen using light microscope. Now let's look at the coarse adjustment knob and the fine adjustment knob. So these, they are usually used to focus the image, and they can be used to move the object, the body tube up and down. Okay, if you look at the body tube can go down and up when we use this one, this knob, the coarse adjustment knob. But this one, it just moves the body tube slightly such that you cannot even tell whether it is moving, but they both move the body tube up and down. In simple terms, they bring the objectives nearer the specimen or away from the specimen. Now, when you are using coarse adjustment knob, you have realized that It is coarse adjustment knob is moving body tube at a larger extent, and the image formed by moving the coarse adjustment knob is not usually very clear. We say it brings object into rough focus. Reason as to why it brings the image into rough focus is because image move in and out of focus very quickly, so it is difficult to adjust the focus. And again, if you use this one and you're using the high objective lens, it can easily crash the specimen or the slide, the microscope or the microscope slide. Look at that. So that's why you are told care must be taken when you are using high objective lens. When you are using the coarse adjustment knob, it can easily crash. If you can bring the camera closer, yeah, exactly there. So if you keep moving up and down, it can crash. So care must be taken so that you make sure that it does not crash the specimen. But for these other ones, there is no problem. There is no given time that it will ever reach the stage. So having said that, now looking at the fine adjustment knob, we have said that the body tube is moved very slightly and brings the image into sharp focus. The reason is just the obvious. The image is moved, the body tube is moved slowly, and therefore it is very easy to focus the image and bring it into sharp focus. Another thing that we can look at is the arm. This is what we use to own. And when you can look at the arm, it is holding the objective and the body tube in place. And finally, the base. The work of the base, it provides a support that bears the weight of the whole microscope. So that is what I had prepared in this tutorial. Thank you for watching up to the end. Again, don't forget to subscribe and share widely. See you in our next tutorial.